And this brings us to the description of the figure of merit. This is something that we wanted to talk about specifically here today because the figure of merit isn't simply one property measurement. It actually brings five aspects of material performance into one unified physics grounded index that really allows for a nice holistic approach to the characterization of materials. Of course, individually, each one of those properties is important. However, being able to take this more fully well-rounded approach gives you the ability to really identify which sample is truly going to perform not only on the thermal side of things, but you take into consideration, the pumps that have to move the fluids around, what happens in terms of when they are exposed to temperature, how their physical and thermal properties change. This is what we're going to be really kind of centralizing all of the performance rankings around here today. And of course, that's why C-Therm, we provided the thermal data, and Wasif will be taking us through the data characterized at the Center for Industrial Rheology.
So how do we measure whether a fluid is actually good at moving heat? Not a single property measured as a part of this study entirely captures heat removal on its own. That's exactly the multi-property approach OpenCube project took in their immersion fluid specification. Instead of chasing individual properties, they bundle them into a figure of merit. Each of the formulas that roll several properties into a single score and tell you how fast or how effective heat is removed. The first one, figure of merit 1, captures natural convection. Heat carried away by the fluid rising off the components on its own from a differential in the temperature and density, which produces a buoyancy force. There's not a pump involved. Higher is better. The spec sets two tiers, 35 and 45 at 20 degrees, 25 degrees Celsius. OCP calls for this and is their recommended best real world indicator of performance. The figure of merit 2 is for forced convection, how the fluid performs once a pump pushes it through a system. Again, higher is better, with a threshold of 19 at 25 degrees Celsius. And FOM 3 is just purely the viscosity, and it's flipped in the sense that lower viscosity fluids are preferred.